Hello, we need to talk about balancing chemical equations, so let's go ahead and get to it. So here I've got an example of a chemical equation, but it's not balanced right now, and we need to balance it. So how do we do that? Well, first thing I always do is rewrite it. So I've obviously got it written in front of me here, rewrite it, and I like to give myself some space. I kind of spread things out a little bit. Next thing I like to do is find the arrow in the chemical equation, and I will draw a line underneath it. That is my workspace, and that separates my reactants from my products. So I know that they're on opposite sides. The next thing we need to do is, I like to say we list the players. So we figure out what atoms, what elements are involved here, and we list them out. So I see sodium, Na here, so I'll write Na. And I also see Cl. Those are the only two involved. They need to be written on both sides because Na and Cl are also involved over here. Now, if you remember the law of conservation of mass, whatever you start with, you have to end with. So if I start with Na and Cl, I also have to end with Na and Cl. The other important thing is that we have to start with the same numbers of each atom, and that's where the balancing comes in. So the next thing I like to do is look at each player and count how many there are on that side of the equation. So for the NAs that are present on this side of the equation, how many are there? Well, there's just this one, so I'm just going to write a 1 there, okay? This Cl, how many Cl's are on this side of the equation? In this case, we've actually got 2, so it only shows up right here, but this little 2 right here tells us that we have 2 Cl's. This is actually a molecule where 2 chlorine atoms are bound together. So I'm going to put that I have 2 Cl's over here. Next, we're going to look at how many we have on this side. So Na, I just have one of them right here. There are no little numbers telling me anything different. And I also have just 1 Cl. Again, no little numbers there either telling me that I have anything any different. So again, the law of conservation of mass, we have to have the same numbers of things. So my sodium is balanced. That obeys the law of conservation of mass. But I can't start with 2 Cl's and only end with 1. That breaks that law. So I have to change some things. Now I can only ever add more molecules or add more stuff to this equation up here. So I basically can't take away one of my Cl's, but I can add another Cl over here. And the way I do that is by putting a big 2 right here. So you might remember the vocab, we said that these little numbers are called subscripts and these big numbers are called coefficients. So coefficients, those are the only thing that we can ever add into one of our chemical equations. So if I add that big coefficient 2, that means now that I have 2 Cl's. So I have 2 NaCl molecules, which means if I've got 2 of them there, I've actually got 2 atoms of Cl. So what I'm going to do is cross this 1 out because now I have 2 of those. But it also changed the number of Na that I have, right? Because now I have 2 NaCl. That means I have 2 Nas and 2 Cl's. So I need to update that as well. Okay. So now I fixed my problem with the chlorine, but my sodium got screwed up, but that's okay. I can easily fix that. So all I need to do is, again, go back to the other side. I need to add more Na over here. I need to get to 2 overall. So I'm going to take my Na here and basically multiply it by 2. Now that 2 changed how many Na I have. That time it didn't change the Cl because these are 2 separate molecules happening in this reaction. So only my Na was changed there. So I changed that. And now we have a balanced equation that follows the law of conservation of mass. I've got 2 Na on each side and 2 Cl on each side. So there's your final answer. You had to add a coefficient there and there. That's our balanced equation. Okay. Let's look at a couple more examples here. I think that this is the next one that I want to do. All right. So again, first step is going to be drawing the line underneath the arrow. Next step, listing our players. So this is one of the reasons I told you that capitalizing your element symbols, I'm pointing at my periodic table over here, the reason why capitalizing your element symbols properly is important. We know that each time we have a capital letter, a new element is starting. So I have carbon here and hydrogen here. I know that those are two separate things because they are two separate capital letters. I also have an O. So C, H, and O, and again, same things over here. I have O in two places, that's okay. We only have to list it one time. We'll count it in both of those places, but we only have to list it one time, okay? All right, so we've drawn our line to separate our reactants from our products. We've listed our players. Now we need to count how many are on each side. So for the carbon, I only have one over here. Now this little 4 right here only applies to the H. If there was a little number right here by the C, then it would apply to the C. But in this case, we just have one carbon here. H's, again, just focusing over here. I've got 4 of them. That little 4 tells me I've got 4 of them. And O's are only right here. I've got 2. Let's look at the other side. Just one carbon. Again, no little number right behind the C, so just one carbon. H's, I've got 2 of them right here. That little 2 tells me I've got 2 of them. And O's are a little bit tricky, but you can handle it. I've got 2 O's right here, plus I've got another one over here. So the 2 plus another 1 is 3 altogether. All right. So let's look at how we can balance this out. So our carbons are already balanced, but our hydrogens and our oxygens are not. So how can we adjust that? Well, a good place to start would be balancing out our hydrogens. So if I have 4 of them over here and only 2 over here, so what I can do is multiply where my hydrogens are here. I can multiply that by 2. So now I've got 2 times 2. So that's 4 hydrogens. Okay, so I've got 4 hydrogens. But again, since this is a molecule where I've got hydrogen and oxygen involved, I actually changed my number of oxygen as well. So now I've also got 2 oxygens here instead of I only had 1 before. Don't forget about these 2 oxygens. So now I've got 2 oxygens here plus another 2 oxygens here for a total of 4 oxygens. And I didn't change my carbons by adding that 2 there. All right, so I've got my updated list. Now let's see what's balanced and what's not. Our carbons are balanced, our hydrogens are balanced, our oxygens are not. I've got 4 of them over here and only 2 over here. So let's add some more over here. Oxygen only appears right there. And I need to get it to 4. So 2 times what is 4? 2. So if I put a 2 there, now I've got 4 oxygens. And again, I didn't change my carbons or hydrogens, only the oxygens there. So now we've got our balanced equation here. Adding a 2 there and a 2 there, right? I think I've got time for one more. Let's do one more. Perfect. This is a good one. So, got my equation written out. Line to separate. List our players. Again, here's a lowercase letter, so I know that this belongs together. That's the same thing that happened here. This is a C and a lowercase l. So we have Fe and Cl, just 2 players in this one. Fe and Cl. Make sure you always list these in the same order, by the way. It just makes it easier to compare your lists. So how many Fe do I have over here? Just the 1. Cl, I have 2 of them. Over here, I've just got the 1 Fe, and I've got 3 Cls. Okay, this one's a little bit tricky because you can't quite easily multiply 2 by anything to get 3. We can't put decimals in these. So in this case, we actually need to think of our least common multiple. So what do 2 and 3 both multiply to? Often it's just, if you multiply these together, what do you get? So in other words, I need to make these CLs equal. So if I multiply this 3 by 2, now that changes a couple things over here. Let's recount. So now I have 2 Fe instead of just 1. And my CLs, I have 2 times 3, so I've got 6 CLs over here. Okay. Now let's look back at this side of the equation. Let's still keep focusing on our CLs for now. So I gave myself 6 over here. I multiplied that 3 by 2. Now I'm going to take this 2 and I'm going to multiply by 3. Now I have 3 times 2, 6 CLs. I know it's kind of confusing. A lot of this is going to be a lot of trial and error for you as you get started, but once you get a couple of these under your belt, you'll start recognizing patterns and they'll become much easier. So now I've balanced my CLs. I've got 6 on each side. Putting that 3 here only affected the CLs, but my FE is unbalanced. Luckily, this is an easy fix. I've got 2 over here and only 1 over here, so let's just multiply this by 2. Now I've got 2 FE over here, and as you can see, I'm all balanced out now. So there's how we balance that one, adding these coefficients in front of our equation. So hopefully this is a decent brief introduction to you guys on how to balance chemical equations. Again, some of this is trial and error, but I think once you start doing them, you'll get the hang of it, and it's really not too bad. Some people actually enjoy them. I enjoy them. They're like little puzzles. But if you have any questions, let me know, and good luck.